Most people can calculate an average but have no idea whether that average actually represents the data they are looking at. They assume the mean is the universal truth and treat it as the only summary that matters. What actually happens is that a few extreme values yank the mean away from where most observations live, and the reported average ends up describing a place almost nobody occupies. Picture yourself quoting an average salary to set expectations, the room nodding, and months later learning that typical hires still cannot afford the neighborhood because the center you used was not the center they live in. There are several ways to summarize a typical value, and they answer different questions even when they are computed from the same data. The mean is what you get when you imagine pouring all values into a single pool and then sharing that pool evenly across all cases. It is sensitive to every data point, which is a strength when you want the full story and a weakness when a few points dominate the story. The mean is also the balancing point of the data, the place where the total distance to the left and right, when distances are squared, balances out. That balancing picture is the right starting mental model. Imagine the values laid out on a number line and think of each as a small weight resting at its position. The mean is the spot where a seesaw would balance if you dropped the fulcrum there. Move a single weight far out to an extreme, and the seesaw tips. The balancing point has to slide toward that outlier to keep things level. The median answers a different question. Line up the values from smallest to largest and look for the middle position, the point that has as many cases above it as below it. In that lineup, a faraway giant value does not yank the middle. It just sits at one end while the middle stays put among the bulk of the data. This is why the median is called resistant or robust. It listens to the crowd, not the shouters at the edges. The mode asks which value shows up most often. If you are dealing with categories, shoe sizes, or any setting where repetition matters, the mode tells you what is most common rather than where the center of mass or the middle position is. You can think of it as the peak of a histogram, the tallest bar if you counted frequencies. When people ask what is typical in a categorical sense, they often mean the mode without realizing it. If you run a shoe store and most of your customers buy size 9, the mode is the answer you want when ordering stock. You would not use the mean of sizes, and the median would only be a rough proxy for stocking decisions. The mode pins the most frequent request, which is exactly the operational decision target in that scenario. It is a different kind of typical, the kind that maximizes how often you guess exactly right. That same idea becomes fragile with continuous measurements. And if your values can vary smoothly, the exact most frequent value depends on how you bin or smooth the data. A tiny change in bin width can move the apparent peak. In those cases, mode is more about the presence of clusters than about a single perfect value. If a single tall hump dominates, mode, mean, and median often cluster together. If there are multiple humps, the story is about groups, not a single center. Consider salaries in a young company where a founder is paid about $500,000. If the rest of the team earns broadly similar but far smaller paychecks, that single extreme stretches the mean into a place that no regular employee actually earns. Report that mean as the typical salary, and you will set expectations that later collide with reality. The outlier was real, but it told a different story than the one you needed. And in that setting, the median would stay near the pay of a normal team member because it ignores how far an extreme value is and listens only to how many values sit above or below. The mode would tell you the most common pay bracket, helpful if lots of people are clustered around a standard level, different summaries, all computed from the same data, but only one of them answers the hiring question accurately. The data did not lie. The choice of summary did. The most common beginner mistake is to compute the mean by habit and stop thinking. Habit builds a reflex. A spreadsheet column of numbers triggers an average function, and the result gets pasted into slides with a confident label. That reflex silently assumes the data is symmetric and not heavy in the tails, and that the goal is a balancing point. When those assumptions fail, the mean becomes a misleading narrator. That mistake is not philosophical, it costs real outcomes. Job offers overshoot or undershoot what candidates expect. Customer support teams plan for a typical handle time and then get crushed by many longer calls because the distribution has a long tail. A health department quotes an average age that scares people needlessly because almost all cases are younger, but a few late cases drag the mean up. The correction is methodical and quick. Before summarizing, sketch the shape in your head or on a napkin. Is it symmetric or skewed? Does it have long tails? Does it have more than one hump? Is it categorical or continuous? If it is roughly symmetric with no long tails, use the mean and report it plainly. If it is skewed or you suspect outliers are real and influential, reach for the median as your default and consider also showing a resistant measure like a trimmed mean if the context values the mean but hates extremes. When categories or discrete choices drive the decision, pick the mode because you care about the most likely request, not the center of gravity. In a data set with clear clusters, mention the clusters and their modes. Do not pretend a single average explains all the groups. When the audience needs a single headline, choose the summary that matches the question. Share out fairness points to the mean. Typical case points to the median. Most common request points to the mode. Tie the summary to the decision you are about to make, not to habit. There's a deeper reason these choices work. If you measure error as the squared distance between your guess and the actual values, the mean minimizes that total error. If you measure error as absolute distance, the median minimizes that. If you measure success as exact hits, the mode maximizes your hit rate. Your choice of average is a choice of loss function. It encodes what you want to get wrong less often. Now look at a data set with two clusters, like commute times in a city with downtown residents and distant suburbs. A single center lands in the valley between the peaks, which is exactly the commute almost nobody experiences. The mean sits between groups because it balances them. The median sits at the point that splits the counts, and the mode exposes the peaks themselves. In this case, a single summary is a poor description. The right statement names the groups, not a lone average. Another frequent error shows up when computing the median sloppily. People forget to sort the data before taking the middle, or they mishandle ties and identical values. The correct process is simple. Order the values, then locate the center. If the list has a split center, average the pair in the middle locations. Do not overthink it, but do not skip the ordering step. Without ordering, median is undefined. Mode has its own traps. On continuous variables, picking a bin width too small makes noise look like a crowd. Too large and you blur real structure. If you must state a mode on such data, show your binning choice, or admit it is an approximate peak. When the aim is to detect clusters rather than name a single peak, a smooth density or simple visual is more honest than a raw modal value. Weighted averages deserve a mention because real decisions often care about importance, not just counts. A grade computed from different assignments should weight large projects more than tiny quizzes. A national average price should weight big cities more than small towns. When weights matter, the naive mean understates the influence of heavy components. The mental model stays the same. A weight is just a heavier point on your seesaw, and the balancing point shifts accordingly. Missing data and caps distort summaries in predictable ways. If high incomes are underreported or hospital stays are censored because patients leave the system, the mean can slide downward by sheer absence of the long tail. The median often moves less under such censoring, which is why median household income is popular in reports. Averages do not rescue you from data quality. They amplify whatever the data contains or omits. Sampling size changes how much trust you should place in any summary. With small samples, all three summaries wobble, and a single odd value can alter your conclusion. With large samples, the mean in particular stabilizes under repeated sampling. That stability is not the same as honesty about shape. A very large sample from a skewed distribution still produces a precise but misleading mean if you pretend it represents a typical case. Precision and representativeness are different axes. Always check both. Units and transformations matter too. Add a constant to every value, and all three summaries shift by that constant. Multiply everything by a constant, and all three scale accordingly. Change of units does not change the relative story, but mixing incompatible quantities does. Never average ratios from mixed denominators without standardizing. The result may look clean and still mean nothing. The last practical note is communication. People hear the word average and assume the mean. Say which summary you used and why. If the question is about a typical person, say median. If the question is about what you should stock or expect on a typical request, say mode. If the question is about planning resources fairly across everyone, say mean and admit if extremes will tilt the plan. Here's the mental shift that fixes most confusion. An average is not a truth serum. It is a choice about what you want to represent. Mean answers the balancing question under squared loss. Median answers the typical position under absolute loss. Mode answers the most frequent case under exact match. Pick the summary that matches the loss you care about and the shape you actually have, not the one your spreadsheet suggests by default. Next, we tackle why variance and standard deviation matter more than the average, because once you know where the center sits, the very next mistake is ignoring how wildly the data spreads around it.